Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and I'm going to cover a neat idea that we see in a pre-calculus class to where I'm given a transformed function and I'm trying to find the original function. So in this example, I'm giving you f of the quantity x minus 4 is equal to this quadratic x squared minus 2x plus 3. I want you to find the original function. So what I want you to understand is what this thing actually represents over here is that original function, this f of x, but this thing has been shifted to the right 4 because I've taken all my inputs and I've done an x minus 4 for those. So what I want to do is, how would you shift it back? So how do you undo that x minus 4 shift? Okay, so well, I'm glad you asked. So what I'm trying to do here is this is going to be my input. Everywhere there's an x is what I'm allowed to input. So if I want to find the original f of x function, what I'm going to do is instead of evaluating this at f, I'm going to evaluate this at x plus 4. So what I'm going to do is really, it's a composition, is I'm going to compose this function here with x plus 4. So when I rewrite this, our f of, remember, x is going to now be this x plus 4, and then I'm going to have minus 4, is equal to, we have x squared minus 2x plus 3. Now, everywhere there's an x, there's now going to be an x plus 4. There's going to be an x plus 4. So what I've done is I've evaluated this shifted function right, and what I've done is evaluated at this x plus 4 is going to shift it back to the left 4. So we can see that this expression here, that the plus 4 and the minus 4 are going to annihilate. So this is just going to be, f of x. And over here we have some simplification to do, assuming we want to get this in some kind of a general 4 quadratic. So I know in order to square that, I have an x plus 4 times x plus 4 minus 2 times x plus 4 plus 3. And then squaring this, we're going to have x squared, outside's 4x, inside's 4x, so we're going to have 8x in total plus 16. I'll multiply this as well, so minus 2x minus 8 plus 3. Then we'll combine all our like terms, and we shall be done. So this is going to be x squared. I'm going to have a 6x, and then 16 plus 3 is going to be plus 19. So what's interesting is if you do graph these two functions, that the graph of this and the graph of this are really going to be nothing more than a shift, left and right of 4 units. So let's do maybe 2 more. I want to do what happens if I have a product in here and what happens when I shift things up and down, and that'll be kind of the last idea for this. So let's see. So say I have the expression, the equation f of 5x is equal to the square root of 10x plus 2. What I want to do is I want to find the untransformed function. So what we know is an input of 5x is actually squishing this thing squishing this original function by a factor of 5. So the way we undo that is we're going to have to unsquish it. So again, for the very similar idea is everywhere you have an input, which is going to be x in this case, you need to evaluate this function at its well, you have to undo it essentially. So how do you undo a multiplication of 5? Well, you're going to divide by 5. So what I'm going to do is I'm going to evaluate this at x divided by 5. And what this is going to do is this would horizontally stretch it. So everywhere there's an x, now there's going to be this. So this is going to be f of 5 times that x divided by 5. And similar for this x is going to be the square root of 10 times x divided by 5, and then we still have this plus 2. All right, now we'll simplify. I can see that the 5s will cancel here, so this is simply going to be f of x. And over here, I built it to be kind of nice. 10 divided by 5 is going to be 2, so this is going to be root 2x plus 2. All right, one more. Let's do a horizontal transformation and then also a vertical transformation. And we'll keep it simple. Maybe we'll do some more examples so this can get more complicated, but I'll give you an idea on how to do that as well. All right, so for this last example, I want to do this. I have a function that says f of the quantity x plus 3 and then minus 2 is equal to this quadratic x squared minus 4x plus 4. I want us to find the original function f. And again, what does this stuff do? What does the x plus 3 do? Well, composing the function with x plus 3 into the input is going to shift it. We have this left 3, and this subtraction of 2 is going to take that function and shift it down. So what this is a transformation on this function, so I have to undo these transformations. So in order to undo the x's, I am going to, I have to evaluate this function at, x minus 3. So we'll do it one at a time, just to kind of explain how this negative 2 is done. We could do it both in one shot, but it might be nicer to see with the work. So, f of, everywhere there's an x, there's now going to be an x minus 3. So this is now going to become x minus 3. This will be an x minus 3. We're going to have an x minus 3. So x minus 3 plus 3 minus 2 is going to be equal to that x minus 3 squared minus 4 times x minus 3 plus 4. So again, everywhere there's an x, now there's an x minus 3. When I simplify this side, you can see that those 3's annihilate. So this will become f of x minus 2. And over here I have this is going to be x minus 3 times x minus 3 minus 4 times x minus 3 plus 4. I know that you probably know how to square these binomials, but people make the mistake of outside and inside if you're not careful. So this is going to be x squared minus 6x plus 9, and then same thing, I can multiply this, minus 4x plus 12 plus 4. So when we're done simplifying, I'll have x squared minus 10x. 9 plus 12 is 21, plus 4 is 5. Okay, so the last thing I now need to do is unshift it. So this is now, this function has been shifted, down 2 units of this particular function. So if I want to find f of x, what I'm going to have to do is I'm going to have to shift this function up 2 units. So I'm just going to have to add 2 units to that particular function. And same thing here, if I want to shift, this function up, I'm just going to add 2 units to this side. So you can see that the way you handle your horizontal transformations, at least I'm doing it, is quite different than the way you handle your verticals, because horizontals are at the input, and then your vertical transformations are operations outside of the input. So then you can see that these twos are canceled, so this is simply going to be equal to f of x. And then over here I have x squared minus 10x plus 27. So if you like the content, please subscribe.